And it's a great privilege for me to be here today. I started my career physical geographer, working on soil erosion, river sediment dynamics. Started my career over 20 years ago. And when I started my career, I was using farms and rivers in Devon as a natural laboratory within which to build academic tools and techniques and models. And it was during that process, quite early on, the realization was, talking to farmers, that a lot of the answers or ingredients to the answers to our research questions were actually within the agricultural community. And then as time's gone on and that realization has developed, it's also that the research questions that we need to address as academics are also in that research community, in the agricultural community. So I think the engagement between the research community and the agricultural community is really important. And for us to get that steer to make our research really relevant to the real world is absolutely fundamental. So for me, it's a great privilege to be here and to be chairing this session on emerging technology, soils and carbons. And we've got a really interesting program. I think the idea of looking to the future is a really good point that was made just now, because we're going to start off thinking about emerging technology, agricultural technology, thinking about how we can rethink production, food production and productivity. And then we're going to move into the really complex topic of soil carbon. And I think we all appreciate the importance of soil as a carbon reservoir, way more carbon in the soil than in plants. But also the concern that soil carbon amounts are in decline. But alongside that, the realization there's innovation potential at the farm scale to really enhance soil carbon, to manage it better, to mitigate climate change, but also to provide those added value in terms of soil health and productivity. So it's a complex space, and while we've got win-wins in terms of carbon enhancement, there's also a lot of debate about management, about mitigation, about markets. And so that complexity of the carbon question is something that I think our speakers are going to expose to us really nicely today. And at the end, we'll have a chance for hopefully some good panel discussion and questions from the audience to explore those debates. So without any further ado, I shall hand over to Professor Mick Fuller, our first speaker, to talk about agri-tech innovation. So over to you, Mick.
Thank you, Will. Morning, everybody. It's a pleasure to be here. Some of you might know me before because I was hanging around Silhane for a little bit, and I still am secretary to the Silhane Education Trust, and Harry is one of our trustees, and we do good work in sponsoring research projects at the university and beyond. I'm just going to give you a flavour of just some of the innovations that are beginning to have impact in agri-technology. One in particular I'll finish on, which is my line of research. And to let you know that this research is being done here in Devon. And I think that's important, and I'll come back to that at the end. There is high-level research being conducted here in this county, and it's really innovative stuff, and it's trying to feed into a large number of networks and have impact for you in the future. So it won't be for everybody. It won't be immediately, but these are some of the things that I get excited about, and I hope you get excited about too. So I'm going to say a little bit about robotics, a little bit about space technology. We know about that from precision farming, but where has it gone to now? Where's it going? A new thing is about sensors and diagnostics and imaging of plants and trying to understand how things are working. And then my own, if you like, pet interest, which is plant factories, and where that is going within the UK and elsewhere in the world, because that is really highly controlled environment agriculture. Again, not for everybody, but for those people who do want to get into that, there is a serious technology revolution going on. So first onto robotics, and many of you, especially for dairy farmers, you may well have some robots in your parlours or your sheds helping you to move muck around or to clean things up, and that's just the beginning. One of the big things that is holding back robotics and the application of robotics to agriculture is the fact that we got this chaotic environment. You know, it's very unpredictable. It's already mentioned earlier today. The weather changes, the topography changes, the soil type changes, and how do you build a robot to weld something to fix it in your farm? You can't do that because the robotics that are being used in industry that we heard about this morning are very precise. and they're hard robots. And the trouble with a hard robot, it can only put something into a single space. And that space has to be the same every single time. And some of the robotics I'm going to talk to you about that have been developed at the University of Plymouth, led to spin-out companies, are actually really working in the agricultural landscape and actually are really taking that sort of soft technology on board. So what do I mean? This one here, Robotics, is an agricultural robotics platform that has really taken on from some of those earlier research platforms that were developed elsewhere in the country, which effectively don't work. And they don't work because they produce something that's either too heavy, too cumbersome, or can't find its way around a field. What we've done at Plymouth, what our team has done at Plymouth, is to build these lightweight platforms, but with incredible power in them, and to build a framework on which you can attach sensors and robotic arms and things to do things. And have tested it and have tested it and have tested it out in the field. And the important thing is to get it to work in the field and then to value engineer it and make it affordable. So this is the sort of rig. It may not look what you expect it to look like. It's not a big robot that's got a face on it and arms and all the kids can fall in love with. But it actually is a very small but powerful unit that can traverse a field. And we've used it in Devon and in Cornwall, on hilly ground, sidling ground, and on flat ground, and it equally performs well. It's got so many sensors that you can add to it. It knows exactly where it is and exactly where it's going. So its GPS navigation is really precise. And as well as that, it has a really powerful battery system on it that means it can keep going for 24 hours. And that's the beauty of all these robotics. It's not that you've got to stand there and watch it do what you would normally do whilst you're driving the tractor. You can actually set it going and trust it and come back so many hours later and it's actually done its job and completed the tasks. And that is a really important development for the robotics industry. So this is a bit more of a look at the rig that sits on it. It's lightweight metal that you can attach all these things to. A lot of these are sensors that have been put onto it, but also you can attach arms to it to actually do things. And they've actually got an arm that can use to plant trees. So you can actually send it to various locations and it will actually plant a sapling for you. And that's just an example of one of the tricks that it can do. But there are other robots that are being developed and have been developed at Plymouth, and this is another spin-out company called Fieldwork Robotics. And this is what I was talking about soft robotics. The real innovative part of this robot platform is it doesn't actually have to have a precise place in a precise location time and time again. And it has this soft arm robotics. You can see a model of the arm there. What actually, if it gets bashed by something, just comes back and knows where it is. If you bash the arm in a car factory of a robot, basically you've screwed up the whole production process and you have to go and fix that robot. These robots have got so many sensors on them and they've got such soft dynamics to them that they can negotiate the unpredictable agricultural landscape. At the moment, you can see this is in Cornwall. And this part of the project was to try to develop this robot into picking cauliflowers. One of the most complicated things to do because you're in the middle of January in the field with the rain coming down and you've got real challenges to get this robot to work. But they're a long way down the road to getting that to work actually in the field, and that's really fantastic. But more importantly, they've gone into fruit picking. And they can get an adaptation of that hand, which has just got two fingers, and it can pick a raspberry and put it into a punnet. Now, if you think about it, I can't pick a raspberry and put it into a punnet without the risk of squashing it, but the robot can do it without squashing it. And you can set the robot going all night long, picking the obvious raspberries that are ripe, because it has a colour sensor on it and a texture sensor on it, and the morning when you come in, half of the raspberries within your polyton or your greenhouse have already been picked and boxed for you. And this has tremendous implications for the soft fruit industry. Not only raspberries, but we've also adapted it to pick tomatoes, and you know tomatoes are grown in greenhouses in an intensive way, and we can set the robot going and it will also pick the tomatoes in the greenhouse too. So much so, there's been such a successful technology development that the guy who's leading it there, Martin, has actually left the university to go full-time in his business, and that business has picked up several £1 million worth of contracts with soft fruit growers, and not just here, but around the world. And I was lucky enough to be in China with him when we were picking tomatoes for the Chinese Development Agency too. The second bit of technology I want to talk about is really space technology and the Agri-Living Lab. Now, the Agri-Living Lab has got a stand at the back there, so if you want more details, you can please go and talk to them at the end. And this is the Southwest's contribution to the catapult for space technology applied to farming. And you can see the network of hubs that it's developed and is enlisted. So this is a multi-million-pound, multi-person endeavour to harness the data that comes out of satellites up in the sky, from drones that fly over and collect data, and put that together into a system that can assist in the management of particular farm practices. It's really multifaceted, and the Southwest has got a stakehold in this. It's a very small map down in the bottom left-hand corner, but you can see that involves Rothamsted, Northwick, Exeter, Plymouth, and some places in Cornwall too, all contributing to this platform to assist in the development of that precision farming in the future, and that's something to really look out for. And these are the sorts of challenges it looks to address. It's actually engaged with farmers in terms of developing the questions that farmers want answers to, and then trying to design the data interpretation to meet those challenges instead of the other way around. In the past, the other way around is right, we've got some fabulous technology that's come out of the military to GPS everything. We'll produce something and we're sure we'll sell it to farmers. They've changed it around and asked farmers first what they actually wanted, and then tried to work out the data interpretation to meet that challenge. And that's a really important way around of doing things. That's coupled with so this is the Agri-Living Lab, and as I say, they've got a platform back there to have a look at. But this is coupled with something that we've been developing at Plymouth, and I know Will has been involved with this too, and that is a mobile lab. And yes, you can look at that. Yeah, it's a little horse box. Yep. Can be towed on the back of a car or a Land Rover to get to an individual field. But what is packed inside that lab are all the sensors and testing kits that you could possibly assemble in order to test the soil in the field at the point of actually sampling. And this is proving to be really, really interesting to be able to set up a potential service to farmers to be able to come and deliver some of the questions or the answers to the questions you need in terms of your soil carbon and so on. Some of the sensors that are being developed are so sensitive we don't really know what they mean yet until we've interpreted all the data they're generating. So some that have near-infrared spectroscopy, others that have got graphene sensors that are really doing exciting things. And I know I can't show you one now, and I can't give you one, and you can't take one away. Again, this is a technology to be aware of, because it will actually give you data that is really important to you in the future. The last two things really is diagnostics, and again some DNA technology coupled with some light imaging technology to be able to detect diseases. This has become so much more sophisticated than it was in the past, where you just had a microscope to look down. Now you can actually detect and characterize the fungal infestations in a particular crop much more readily, much more easily, a lot more accuracy. And then finally, plant factories. Plant factories are controlled environment agriculture, where you can control the nutrient solution you grow the plants in, you can control the lights that you grow the plants under in terms of LEDs, and you can produce something like this in a warehouse which has got a bit of refrigeration in it. And these are realities. People are entering into these. Mostly it's for baby leaf salads and herbs, but also they're adapting these to the pharmaceutical industry and producing crops that you can extract predictable compounds that are used in pharma. The biggest vertical farm or plant factory in the world is being built and is near completion in Gloucestershire. It's from Jones Foods, and they already have one factory up near Hull, where they are producing 25% of the basil crop of the UK in one place. Now, that is really intensive, but it actually is working for them because they've got an energy generation system alongside it. And that's exactly what's going to happen in the one in Gloucestershire. There won't be human interaction inside this factory. Now, you may think that's a horror story of intensification, but actually this is one way to address 365-day-a-year production, and that is a real attraction for that supply industry of those fresh herbs and salads. Era Farms in the US has already moved into this. They've got a massive investment, and a huge amount of the lettuce production in the States, particularly in the winter, is put through these factories. And if you look at the economics, the whole industry is moving out of its Cinderella phase and actually into a production phase. And even us, with a very small research grant over the last 5 or 6 years, have been able to engage an awful lot of companies around Cornwall and Devon in looking at this technology, and to attract the interest of royalty. Not that I want to brag about that, but you'll see Princess Anna and you'll see some friends from Saudi Arabia, where we've already transferred this technology and working with them on the research to meet their food security issues, which are much more acute than ours because they don't have any soil at all over there and a challenging environment. So really that's just a flavour of some of the technologies that are out there. There's a study that's been conducted and sponsored by Devon County Council. They've got a big green display at the back of the room. And that's about looking at agri-tech in this region. And we may think, well, there's no agri-tech in this region. We're a lot of farmers, we're lots of grassland farmers, lots of dairy farmers, some arable farmers, but we don't have any agri-technology along the lines I've been talking about. But believe me, all of what I've showed you so far is being researched and developed here in Devon. And this map shows a map of the agri-tech industries that already exist and research facilities here in Devon. And there is an upcoming meeting in March. If you're interested in agri-tech and what it might be able to do for you, then go attend that meeting and find out more about what the opportunities are. It's being put on for you. I would just add the last thing I would say. Our challenge is not just to develop technologies. The technologies are already there and being developed. The challenge is to value engineer it. What I mean by that is to bring the cost down without losing any of the efficiency or robustness of the technology. And if you can value engineer it, then it becomes affordable for everybody. And this is the way that photovoltaic cells have gone into solar farms. Value engineering it down, but don't lose the efficiency, and everybody can invest in it and use it. And I think it's a really exciting technologies. Thank you.
Fantastic. Thank you, Mick. Insights into potential futures that can be shaped by the community. So feedback and your opinions during the question and answer will be much valued. Just also to flag, there are 2 desks at the back linked into some of the agri-tech projects going on at the moment, and there's some sensors there. You can see soil carbon sensors there, which you can see in action, which leads us nicely on into the next presentation, which is moving into the soil carbon realm. We have a trio of presentations taking us through different perspectives. Kicking off is Neal. He's going to be taking us on a deep dive into some of the science behind soil carbon measurement, but also soil carbon processes. So over to you, Andy.
Thank you very much. Hello, everyone. It's a real pleasure, I was asked to help out with this, and it's really great to see it working. And so many of you here, and such a buzz in the room. It really is really exciting to be able to talk to you about some of the science we're doing. But I want to start with two admissions. The first is, yes, it was me. My phone went off, and I've took one for the team so you can all relax. You're not going to be buying the crates of bubbly. So that was the first one. And the second is, Harry spent a little while, right at the beginning in his introduction, talking about faceless and clean-hand scientists who never venture outside of the lab and spend all their time looking at DNA sequences. I'm one of them as well. But I should say, I'm lucky enough to work with, so I'm a biologist myself, but I work with soil physicists and as part of a team, and soil modelers as part of a team. But we're also very lucky, and I very much appreciate the ability to get and speak to farmers and learn from them. And I'll say a little bit more later about what I'm learning from farmers. But I'd like to think, although I spend most of my time in a lab looking at computer screens, that a lot of what I'm doing is inspired by understanding farming and what farmers are trying to do. And I'm really trying to backfill in the knowledge, chasing you in your innovation, trying to build up that support for what's going on in the soil as you're manipulating it in different ways. So I have 10 minutes basically to tell you how soil works. So let's see if we can do that. We can dispense with that. So really the message I want to get across is that soil is a dynamic process. It's not a static physical thing. The more we look at it, the more we realize that it's a living entity, and it responds to the way it's managed. So I would like to think that you will leave here thinking about soil in a slightly different way and think of it as a dynamic living system that you are nurturing, or you can nurture. You can choose to abuse it if you want to. But I think we're all here because we want to understand how to nurture a living system that is the basis for your food production, and as we heard earlier, a lot of the food that we all eat. So I really want to send you home with that sort of message, but also picking up on what Harry said, that the more we look into soil, the more we realize it's really about connectivity. In the same way that, human society is all about connectivity, and endeavors like this today are all about connectivity, we're starting to understand soil as a big part of soil actually being about the connectivity of pore space that allows the biology in there to flourish and do what we want it to do in what many people would like to call a healthy soil. That this connectivity is the basis of a healthy soil. And that connectivity controls microbial metabolism. We now have evidence that microbial metabolism evolves under the constraints of what connectivity is in the soil, and that this has a real important influence upon the efficiency that we use nutrients in soil. So I really want to impress upon you just how important connectivity in soil really is. So I want to start with how we are starting to think about soils as either adaptive or unadaptive systems. Now, I think most of you have probably already got a gut instinct for this. Many people will realize that sandy soils really don't respond and don't sequester much carbon. They don't respond to management particularly well. But silty clay loams, heavier soils do respond very nicely. They do sequester a lot of carbon. And we've been particularly interested in this, the phenomenon of pore space and what's going on there. And we've identified, I'm going to have to walk around, I'm afraid. We've identified that when you look at the pore space and the connectivity of those pores, that depending on how much organic matter you have in soil, that connectivity follows a very consistent path from very low soil carbon soils, which have very little connectivity and very little total porosity, to soils that have an awful lot of sort of maxed out in how much carbon they can sequester, have a lot of pore space and a lot of connectivity between those pores. When we look at sandy loams, although these treatments imposed upon these soils are exactly the same, there's also a range of carbon inputs here, but we don't see pore space behaving in the same way as we do in the heavier soils. One could almost, and we're trying to convince ourselves at the moment, that to make the statement that sandy soils really aren't soils at all because they don't behave in an adaptive and responsive way, it would very much help the way we think about managing these two different types of soils. And I would also say, right now, we're trying to find soils in this loam, clay loam area to fill in a lot of this data. And I think some of those soils are very local to us. So I have an interest in finding people with loam and clay loam soils to get involved in this sort of research. So understanding how systems behave from a sort of connectivity point of view is extremely important. Now, just to show you the relationship between organic matter in soils and this connectivity, I've got some real-world data here of the amount of carbon inputs into a soil across the bottom axis here, and the degree of connected porosity in those soils. And what you can see is there's a very interesting non-linear relationship between these two parameters. There's quite a range of inputs between about 1 ton and 10 tons per hectare, across which there's very little change in the amount of total porosity and connectivity between those. But once you're over this critical threshold, you see this exponential increase in connectivity between pores. And I've got some computed tomography images here of soil aggregates about 2 millimeters in size. The bottom one collected from the very low organic carbon soils. The top one from a permanent pasture that is probably saturated in organic carbon. And what I want to show you is that as these movies progress through, you'll see the pore space inside these aggregates become apparent as yellow, and it'll show you the degree to which you can gain or lose porosity in soil simply by manipulating the amount of organic matter that's going through the system. So what you'll notice in the permanent pasture, a lot of porosity and a lot of connectivity between those pores. In the very low carbon soil, there is still pores, very few of them, and the connectivity between them is extremely reduced. Now, these pores are all about 100 microns or less in size. And we're picking on those because they are the pores that hold water back by capillary action as a soil drains after a rain event. So this space effectively represents water holding capacity of the soil. So you can imagine these soils can hold much more water holding capacity in those soils than these, but also the ability to move that water around, and most importantly, oxygen and nutrients, is much greater in a highly connected system than this one. So just to give you another view of what that looks like. 2 minutes. 2 minutes? You're kidding me. Jeez. All right, well, we might want to stop here. Just to give you an idea of what it's like living in these pore spaces. These are exactly the same aggregates, but now we're going to fly through them. And you'll notice in the top there, lots of pore space, lots of connectivity between them. It's a logistics issue of moving nutrients and oxygen through these pore spaces. High redundancy in the soil that has an awful lot of carbon in. In the pore spaces at the bottom here, you can still find pores, but they're all dead ends. Moving nutrients and oxygen through those systems is extremely challenging. So I'm just going to run through very quickly. Now what we've identified is that this pore space is central to how soil operates because it controls the movement of oxygen, nutrients, and water through the system. It controls water access, or plant root access to water that's stored in the soil, but also, by limiting oxygen diffusion through these systems, can create, in very poor soil carbon environments, an awful lot of anaerobic space, which drives microbial activity into a very negative behavior, which drives off methane, nitrous oxide due to anaerobic respiration. In very highly connected systems, you don't get that increase in those metabolic pathways. So we have this pore space controlling the way the physics of the soil works, which directly influences the microbial genetic component, and that component evolves to suit the new physical constraints in the soil. And you can drive this in a positive way by adding organic matter to that soil, where you get much greater pore space and connectivity. I think it's time I hand it over. I just want to say, we can talk about this later if you want, but in those more connected pore spaces, we see nitrogen use efficiency is increased an awful lot, because we're losing an awful lot less nitrous oxide from these soils that have an awful lot more oxygen space in them. Now, I can hand over to Becky, who's going to talk about measuring carbon. Yes?
Brilliant. Thank you very much. I'm going to stand over here so I can see the clock and make sure that I don't go over. So we're going to zoom out from zooming through a soil aggregate. And for my part, we're just going to start thinking about actually how does this understanding of what's happening with soil carbon have an impact on how we measure what's happening in terms of accounting for carbon at a farm level. So my name's Becky, and I work for an organisation called the Farm Carbon Toolkit. I'm really pleased to be here with you today, talking about all of my favourite subjects, grass and soil and carbon and all those sorts of things. And we really have been around since 2008, really trying to provide practical tools and resources for farmers around reducing greenhouse gas emissions, improving energy resilience, improving business resilience, and with a particular focus on soil health, and how by understanding what's happening with soil health and soil carbon, that can really start to inform what's happening in terms of measuring and managing carbon on the farm. And if we just think for a minute, and I think Robin spoke about this in the first session in terms of some of those ideas about why do we need to manage carbon on the farm? And unless you've been hiding under a rock for the last couple of years, you'll realise that you can't open the farming press, the national press, without looking at something to do with the environmental impact of agriculture. And carbon very much is the bandwagon which everybody is jumping on at the moment. But again, we could replace that with biodiversity or some of these other things. But we're very much focusing on carbon. So we know we have those policy drivers. We know we have this need to look at net zero and our ability to get to net zero, not just as an industry, but also as the UK as a whole, and obviously agriculture's contribution to that. We're starting to see a lot more supply chain pressure. So we're starting to see that farmers are being asked to pick up this information, to measure what's happening in terms of the carbon performance of their farm, so that that information can then be used by their supply chains in terms of declaring their net zero credentials, which we'll talk about in a minute. But if we move away from some of the bigger picture stuff and zoom back down and think about why should we manage carbon at a farm level, well, it makes total business sense. There's this really good relationship between efficient use of resources and a reduction in our carbon footprint. And I think we've heard some really, really good examples from our excellent farmer panel in the first session about how by looking at these sort of things, we can reduce our input costs. And in this era of increasing volatility in terms of those input prices, whether you're doing it from a carbon or an economic perspective, it's going to get you to the same point. But also, managing carbon on the farm allows you to start to change the conversation. It allows you to be more informed and make better decisions. So when you're starting to think about some of those things that you might be doing on the farm, some of those management practices, how you're managing your stock, your grass and your soil, you can think about it from a carbon perspective as well as the financial and practical constraints that you might be thinking about. It creates more resilient businesses. And resilience, I think, is one of those underlying themes that we'll hear a lot about as we go through the rest of today. It provides a positive narrative. And we really need a positive narrative for our industry. We've seen some brilliant examples of farmers who are doing fantastic things. Those are the stories that we should all be sharing in terms of some of those things that we're able to do. It allows us to be more future-proofed, and then potentially we have opportunities in terms of income generation. We also need to remember that as farmers, and again, this has been spoken about already, we're dealing in these complex biological systems. So we've got these gases, we've got the carbon cycle, we've got the nitrogen cycle. We've got this ability, as we've already been speaking about how we can hold carbon on the farm. And so it becomes quite complicated in terms of looking at our role, both as individual farmers and as an industry, in terms of being able to provide these solutions. And managing carbon really starts by being able to measure it. And I think we've already heard this morning from Chris about you can't manage what you don't measure. And I'm very excited about the fact that potentially, Mick, we can have a robot that comes and does your carbon footprint for you. For those of you that it doesn't fill you with joy, it does me. I love carbon footprinting. But I know that for a lot of you, it's not the thing that makes you wake up in the morning and go, yes, today is the day I can do my carbon footprint. But it is that first step in terms of being able to identify the contribution that your farm is making to climate change. And I'm sure we'll have conversations about how difficult and how cumbersome these footprint calculators are. But at the simplest level, all they're doing is they're looking at the amount and the source of those 3 different gases that you're emitting from the farm, and then looks at where you might be able to make improvements or changes to reduce it. Really importantly, your carbon calculator should also be highlighting where you are doing that uniqueness that our industry is able to provide in terms of that sequestration, okay? Because otherwise we end up with metrics that don't fully represent what's happening on the farm. They allow you to become more aware and make more informed decisions, but those metrics that you use need to be relevant to your business, they need to be practical, they need to be consistent in terms of providing that way that we can all measure, and we can look at the variation in our farming systems, but we can have a system that allows us to do that. And they need to be that first step in terms of informing behavioural change. So the process of doing your carbon calculator shouldn't be so hideous that you have to go and lie down in a darkened room for 3 weeks to get over it. You then say, well, actually, what's this information telling me, and what can I actually use in terms of developing my management strategies moving forward? Now, as I've already said, we are the industry that can potentially deliver the solutions. And there is a wide range of claims around how big that potential size of the prize is. We've obviously got modelling that comes from NFU, Net Zero by 2040, that says the size might be about 5 megatons of carbon dioxide a year. We've got Microsoft, who are already selling and buying lots of stuff, which is that graph at the bottom. We've got the 4 per thousand initiative, which says that actually, if we could improve the carbon content of all of our soils across the world by 0.04%, then we would solve climate change. We've got companies across the world with a global wealth of $14 trillion who have all made public commitments to supporting and sourcing their food from regenerative systems. And we've got, as we've already heard about today, the potential improvements in terms of resilience, farm performance, and all those other sorts of things. So it's a really complicated picture, and actually, where do we sit in terms of, does soil carbon offer us the silver bullet, the thing that's going to solve all of our problems? Or does it do nothing, as some people tell us? And are we somewhere in the middle? Where does this bring us when we think about how we can account for this within our calculators? Well, a really interesting thing that we've got is that we've got a lot of supply chains that are now making those net zero pledges. It's a bit of a race as to who's going to get there first. We will be there by 2030, 2025, all these things. But the metrics that they're using, or they might be bringing down onto your farms, aren't actually giving them the information that allows them to get to net zero. We've got a lot of our supply chains that are actually only looking at emissions. And not only does that give us an interesting perspective in terms of when we're reporting that, your ability to get to net zero, they're not measuring the thing that's actually going to get them there. Models are increasingly difficult to use in livestock systems. You know, with our brilliant farmer panel earlier, we had 4 farmers who were all running rotational grazing systems, different soil types, different areas of the UK, different stock types. And all of this complexity and this systems level thinking means that we don't at the moment have those models that allow us to look at the potential for some of these management systems. So therefore we get to a measurement system, which Tom will talk about in a minute, which links a lot of cost and brings a lot of complication. We know, and there are a load of you in this room who are doing brilliant things around soil carbon sequestration. I know, I've dug holes on your farms and I've taken the measurements, okay? And that benefit in terms of what's happening, we should be including that in your carbon calculators, because I know that you are also getting brilliant benefits in terms of improved resilience and improved performance, but the carbon benefit we should be able to include. And understanding how we can do that by focusing on soil health and carbon emissions reductions, as well as that carbon sequestration, will just help frame this in a whole, you know, in a sort of nice package. So calculators are really useful in terms of being able to give us that impact assessment that we need, both in terms of looking at what's happening from a management perspective, but also how we can utilise this unique asset that we've got. But those calculators can also be used to look at, so what? So if you guys are inspired about some of the things that you've heard about today, and you think, well, what would that do on my farm? How would implementing rotational grazing, how would changing the diversity of my species make a difference to me? You can then use the calculator to assess what that would do in terms of potentially improving sequestration, but also reducing emissions. But it's important to remember that none of the calculators are perfect. And I think we've had some great examples this morning thinking about the science and the academic community, which are catching up and actually helping to understand and getting that information, that flow of knowledge from farmers to academia to actually get the answers to some of these questions about how many species do I need to have in my grassland? Is there a difference in terms of the length of my rest period? What happens, as Andy's already said, in terms of soil type? And we need to get the answers to these questions and then feed those answers into the calculators so that we can feel confident that the results that we're getting are a true reflection of what's happening. We are never going to totally eliminate greenhouse gas emissions from agriculture. It is a leaky system and it's biological. But we have the ability to actually reduce our emissions and see that nice link through in terms of to reduction in costs and improved performance. But by understanding and measuring what's happening on your farm, that empowers you with that knowledge, with that baseline in terms of where you are with net zero potentially, and what you can do to make the difference. And it really is data that can help give you the confidence in terms of giving you the evidence and the understanding of what you can do and the impact it's going to have.
Fantastic. Thank you, Becky. Really inspiring talk. And I think that cross-cutting theme of complexity from Andy's world at the aggregate level through to the farm scale and then to that system scale is really important. And if we can harness that complexity and understand it, then as you say, that can bring real transformative change. So yeah, really inspiring. So on the topic of complexity and measurements and carbon, we shall move over to Tom. Will you make it more complex or less for us?
Hopefully.
Pass over.
Afternoon, my name's Tom. Afternoon, my name's Tom. Very pleased to meet you all. I farm down near Foy in Cornwall. I trained as a nutritionist, but have become passionate about soils. My background was high input dairy nutrition, but I soon learned that the guys and ladies who managed their soils, managed their grazing, grew more grass, had more profit and used less inputs. So it's been a long journey. But you as agriculturalists, we as agriculturalists hold an almighty thing amongst us. We as agriculturalists have 80% of the carbon in our terrasphere. Slightly different figures to what's been quoted earlier, but if we raised our organic matter by 1.6%, we would slow climate change down. It's a big oil tanker literally going to a very, very melting iceberg, but we have the potential to do this as agriculturalists. And the byproduct of good farming, rotational grazing, reduced tillage, which you'll hear about later, is you build organic matter. This helps you reduce inputs, helps you store more water. So it's one of those very rare things. It's a win-win-win for all of us as agriculturalists. Each 0.1% rise in organic matter is 8.9 tonnes of CO2 drawn down from the atmosphere and put back into the soil. It can be released again, but we can keep building and building and building. And we in the southwest, where we have rain and we have livestock and we have mixed farming, we're in such a good position to grab hold of this. And what 0.1% rise in organic matter is 2.5 tonnes of carbon. Now, there's a hell of a lot of interesting carbon. There's some Ponzi schemes. There's some schemes I don't want you to get into. Carbon is your byproduct of good farming, soil organic matter. The more you raise it, the more resilient your farm will be. Please measure it, please understand it, please look after it. It could become valuable, it could be cocked up by people in a trading scheme. But it could just give you the idea that you can plan your succession, you can have a retirement fund. And the way things with agriculture is going at the minute, those opportunities are few and far between. So, in the southwest, in the west of Britain, where we have rain and mixed farming, we have blue is good and red is bad, okay? We have fantastically biodiverse soils. We have a lot of biology in our soils because of our mixed farming systems. You could almost put a soil carbon map right over the top of us. Where you've got good soil biology, you've got very, very good soil organic matter. And a lot of the soils that we test are between sort of 4 and 12%, up to 16% organic matter. Globally, it might be 1.5. We are storing megatons on a global scale of carbon. And all our fathers and mothers who farmed before us have helped hold this together. And mixed farming, good grazing is a vitally important part of this. So we're trying to help farmers measure and map this. This is the machines that we work, and we're actually trying with Plymouth University. We've got another sensor on the front of this, but this is a machine that can do up to 80 hectares a day, 160 hectares if you're doing 2 hectare sample points, that GPS marks organic matter. GPS marks the soil sample, so you can go back to exactly the same point and see the journey of your soil. It can sample up to 3 depths. In the southwest, we really find that 0 to 15, 30 is enough, but some of you have got soil down to 50 centimetres. I've never seen it yet, but apparently you have it. And all of this has the potential to store carbon, to be part of the biological cycle. And anything that's below 30 centimetres is quite difficult to get hold of. Not even the most ambitious contractor can plough much below that. So it's pretty well sequestered. It's pretty safe. So what does it look like? This is a 120-acre farm in Somerset. And what you need to see here is that dark blue is high organic matter and green is very low organic matter. You can almost overlay P and K on this on top. Where you've got dark blue, you've got nutrients. You've got P's and K's locked up in the soil. Light blue on the arable ground, much lower resistance, much lower nutrients. And what this is helping, so this is 50 sample points put onto a map to help farmers understand it. How does it help him understand it? He now spreads slurry on the dark blue areas because he's got loads of organic matter there, and puts FYMs back onto the light areas because there's lower organic matters here. He's trying to build this soil. He's trying to reduce his inputs. The other byproduct of this is we're starting to see increased yields of forage off this because we're targeting what the soil didn't have where it was needed. There was a question earlier about a dairy farm. So these are same farm which we've tested over 2 years, 183 sample points that we've gone to exact same points and reanalyzed. You can't tell a lot from the distances you're all at, but there's more blue on the right. This farm, in that 2-year period, raised its organic matter from 7.08 to 8.2. He's changed his grazing regimes. He's using more complex lays. We've reduced nitrogen by 1/3 on this farm, and he's keeping his output. And this is the most important thing. Another question saying, are we compromising outputs by going to these more regenerative systems? We're really not. By targeting your nutrients, we analyze slurries and we use them more accurately on the farm. We've knocked maize out of the rotation and we're putting lucerne in, thereby reducing the amount of bought-in protein, but still maintaining the same outputs from the farm. So understanding your soil, understanding it on a platform level really helps inform these decisions. The outcome of this is so much carbon has been sequestered that over the 2 farms, full disclosure, one farm sequestered about 500 tonnes, one did 7,000 tonnes in this platform. So, and they both show good management, both show a positive soil organic matter over this period. But when we combine the data from the 2 farms, the milk that came off the 2 average farms together had a negative carbon imprint, that they were actually sequestering carbon for each litre of milk, completely going against a lot of the narrative that you as good farmers are being thrown at you, that farming is crap for the environment. It's really not. We are building biodiversity, we're building resilience, and we're putting carbon back down into the soil. So that's actually just to factor those figures there, showing the offset of nearly 0.5 kilo of carbon per litre off those 2 farms. One thing that we are learning, that because our soils are so vibrant in the southwest, that taking bulk densities as part of this is a really important process. And that has left the farm who thought he'd sequestered 9,000 tonnes has actually only sequestered 7,500 tonnes. But the very competitive neighbour who only sequestered 126 tonnes has now done 500 tonnes. So we've soothed his ego as well through the process. But if you are doing this, Becky mentioned it's baselining. If you do take organic matters, take them accurately, take them to controlled depths, speak to Becky and myself, because this is very valuable. Raising that amount of organic matter, it adds resilience to your business, but taking these baselines, understanding your numbers will help you target nutrients, reduce nitrogen, and increase the sustainability of your farm going forward. Thank you very much.
Fantastic, thank you, Tom. I think for me, a real realization there, thinking as somebody who works a lot with data, is the data quality doesn't start in the lab. The data quality starts in the design of the sampling and the local environmental knowledge that's behind the sampling to make sure we get the right samples from the right places, and also that timeline as well. So I think that data quality side in the field is really important. So I really appreciate that. So we've had our journey through from agri-tech, then we've dived into soil carbon. We've gone from the soil scale to the farm scale and into the measurement debates. We can now open up the floor for discussion. Our speakers have kept the time beautifully, so we have 15 minutes of discussion. I wonder if I'm allowed Chair's privilege to start off, because it's a question that's on my mind as I guess coming from the academic side and reading the academic literature. and wanted to know a bit more about the real world. There's quite a bit of debate about soil carbon quality versus quantity. Are we in danger of focusing too much on quantity if climate change is the biggest driver? And we've had loads about soil health today from all of you. So I've got that. There's a question in my mind about quantity versus quality. Where do we focus in terms of the sort of the drivers that are bringing change? So I don't know who would like to start on that one. Looks like Becky's ready to pounce. Go ahead.
I think it's a really important point, and I think it's also worth remembering that why we're doing this. You know, it's not just, you know, although it might be quite fun to see who can do the most. You know, it's not just about, you know, massive numbers. It's actually really important to understand exactly as you say the quality of that soil carbon and also the longevity within the system, because it may well be that you've got something that's incredibly flashy where you sequester a huge amount, but actually then in a couple of years that carbon all goes back out again because it's not bound up in the aggregates that Andy's talking about. Yeah. So absolutely, it's very important to look at, you know, making sure that we don't underestimate what is possible within carbon sequestration, but at the same time, it's actually about turning that into quality, long-term, stable carbon, which actually is going to help from a resilience, from a biology perspective as well. So, and I think that comes down to looking at things like testing frequencies, being able to understand that as biological systems and the fluctuations that will happen, and making sure that we develop a really robust testing strategy that looks at not just the tonnage, but the stability of that carbon and how that is contributing to the biological function of the soil as well.
Yeah. Thank you.
You got something to say? Well, I was just going to say, as a microbiologist, one thing I have observed is that putting a diverse diet into soil, so a wide range of plant species in lays and qualities of biomass going in, supports a greater number of genes on the average genome in soil. So it's all the requirement for function, or you're supporting a wider range of function by providing the soil with a wider diet of inputs. And sort of arable systems that are very monotonous diets have considerably less genes per average genome, if you can sort of get that concept, wrap your head around that. So yes, that quality of carbon is important for sequestration, but we always also know it's important for functional diversity in the soil as well.
There's several things there, which they're all right, but one of the diversity thing is really important. You know, if you imagine I've always imagined the soil like a cow's rumen. The more diversity and diet you put into it, the less extremes you put in. And nitrogen's a brilliant example, because you would never dream of feeding a cow's rumen raw nitrogen. You try it with urea, but you kill a cow, but little and often. And there's people in this room who are growing 10-ton herbal lays mixes. If you imagine that they think that 40% of the photosynthesized energy is pushed down into the soil, and you're growing 10 tons of herbal lay with virtually no inputs, 4 tons of liquid carbon is being pumped down through the root into the soils. If you've got a herbal lay, there's different forms of sugars and acids and things being pushed down into the soil, feeding that biology, which then live, die, and provide nutrients to that next crop. It's this win-win again, that you're providing more nutrients, deeper down, more stable, and feeding much more diversity. So it's a truly win-win. So, yeah, thank you.
Right, thank you. Again, yeah, the importance of process knowledge and how that can drive win-wins, really important at all scales. Right, shall we open up to the floor and see, do we have questions? Yeah, hands shot straight up at the back in the blue shirt there. Is the microphone? Oh, you got the microphone.
My name's Tony Pope. I'm a farmer, consultant, worked a lot of places around the world. I've just got a question for Andy, actually, on connectivity, which is his big theme, but it's a little obtuse. And I'm very concerned at the connectivity between the research stations and farmers. And I really feel that the message doesn't get out. And I just wonder whether, better liaison officers, I know you're all, pouring out smoke over computers and in your labs and all the rest of it, whether you need a liaison officer to make, to ease the way and to ease the pathway.
I think you're right. I haven't got an easy solution off the top of my head. I'm going to blow my own trumpet a bit. If all scientists were as eager as talking to farmers, all soil scientists were as eager to talk to farmers as I would, I think we would all be in a much better place. There would be less academic gymnastics going on in the lab and more learning from farmers. I don't know how to sort that out. I mean, the one problem the UK's got is that we have got rid of all our extension services. They're not making it sufficient money, so that they can't be of any use. And it really frustrates me that as a scientist, we're so far behind what's going on in the field that we can't provide the confidence and the evidence for what you all think you're doing. And I think you're right, that is a real problem, but I don't know how we fix it, because I don't think we're going to go back to those extension services. I need to encourage my colleagues that it's really fruitful to come out here and speak to people more often. I think that's all I can do.
That's a good point, Andy. I think just to add to that, we've recognised a similar challenge, and I've managed to twist the arm of the university to create what we're calling the Environmental Land Management Knowledge Exchange Hub. And the idea is that it acts as that interface between the community and the researchers. And so we've just really got that going. So if anyone's interested in that, and I think particularly the person who asked the question, I think you're exactly the kind of person we need in that community. Because the idea is to draw out the research questions that need to be answered, and then to try and pump prime those with research funding. So it's trying to link the research, sort of the kickstart the research that's relevant. That's really, really where we're at, because it's, as Andy says, there's a lot going on, and there's not a lot of time in lab time to make that communication break. So that's what we're trying to do with this hub, is we're trying to provide resource to actually be that interface.
I'd also encourage you to stay right to the end, because I know in the last session there is a discussion about how we could achieve something collectively rather than disparately.
Yeah, fantastic. Was there any other response to that question, or should we go to another question? Okay, there's an arm waving right to the back by the speaker there. Yes, please, sir.
And I've got the microphone, so I will say that Rothamsted actually do an awful lot of offering engagement, which farmers could take up much more. So there are opportunities there if you engage the other way. It's not just a one-way process.
My question is around the quality of recording, not just carbon, but the whole range of environmental assets that sit on farms. Every industry, not just farming, is going to have to measure its impact on the environment, and many of those industries view agriculture as having some of the solutions to their problems. How close are we to having robust data that can be validated and stand up to outside scrutiny from other industry if it has a potential marketplace?
Thank you. Who would like to make a start?
It's getting closer and closer all the time. The more that work that Becky and Farm Carbon Toolkit that we're doing in terms of verifications of showing that how it's working practically and in the environment. 2 years ago, we couldn't get any of the carbon audit businesses to talk to us. You'd send emails, and it was like, it's like dropping a pebble down a well that it never hit the bottom. In the last 6 months, because of the work that we're all doing in this space and the understanding, they're now coming to us and saying, actually, there may be something within what you're doing. Well, we've known that for 8-10 years, but so it's getting closer. But that's why I think Becky and I would both be passionate that please remember that if carbon does a thing, it's your assets on your farms, and please look after it and cherish it, because it could be a very vital part of what you do as farmers going forward. Certainly the way that you're learning about farming here encourages that sort of thing. So take data, but look after it and nurture it.
So I think from my side, I suppose on the carbon footprint side, we know, as I said, that it is an emerging science, both in terms of the research that's coming out, which allows us to get better data in terms of what goes in. And if we think about what makes up a carbon footprint, it's obviously the amount of said input that you are using as a farmer, multiplied by the emissions factor. Now, those emissions factors are getting better all the time, and we are, working very closely with the research communities to make those better. But it still relies on that amount of that input that you are using. And for the tool developers, there is always this balance about having enough information in those tools that it accurately reflects what's happening on the farm, and also realizing that it's not the only thing that you are doing, and actually there has to be that balanced amount, the time commitment in terms of the data going in. Now, there will be things where technology and innovations around data will help those flows of data much more seamlessly flow. There is obviously challenges around making sure with data ownership and all that sort of thing, but I think there is some innovation that will work there. In terms of if we then look at what's possible from carbon markets, one of the challenges that we have down here is that if we look at the evolving carbon marketplace for agriculture, there is a model-based system which has allowed potentially some of those arable farmers to look at those sort of things. And it's a very simplistic model which basically says if you do these series of 5 practices, reduce till, cover crops, diverse rotations, it will sequester you X tons of carbon, and that is then yours to, as I say, as Tom says, either hold on to or sell into the market. Now, those model-based systems will give you a much lower potential carbon sequestration than if you were to measure it, because they know there's a multitude of different systems, soil types, all the rest of it, and they will always be a conservative estimate. The problem that we have, as I was trying to allude to earlier with livestock systems, is there is such a variation that those models, it explodes the models, they can't cope with it. So then we come back down to measurement, and then for each individual farm, it is then a conversation in terms of how accurate do you need that measurement to be for what you might potentially want to use it for in the future. And this is the key challenge that we have at the moment, is that we don't know what the potential marketplaces might be in the future. Now, we know that we now have the Soil Carbon Code, which came out on World Soils Day last year, which does start to set that sort of framework with which we might want to do some of that analysis and that testing. And I think it's about trying to move forward in a way which gives us that quality and that robustness and that confidence in the data, so we don't end up like we had last week with suddenly all these lots of carbon markets that have been shown to actually not be doing half to what they're supposed to be doing. So we can provide something which is quality, which allows people to get behind it, but also isn't overly bureaucratic, that means that the entry point is either you can't do it from a cost perspective, a time perspective, or a detail perspective. And I think by working on some of the projects, by having pilot schemes, we'll get to the point where we work out where the robustness, the time effectiveness, and the cost of it, there is that sweet spot in the middle. But we're not there yet by any stretch of the imagination.
If I could just add one thing. In terms of sensors, the sensor technology is really moving fast. I think 5 years ago we talked about, I was talking to a colleague who was an old dyed-in-the-wool soil scientist. I said, how can we measure carbon? Because we're going to need to measure carbon to be able to claim subsidy in the future. And he said, well, you can only do it by loss on ignition. And I said, no, I want a sensor that can do it. He said, you're a chocolate teapot. That'll never work. And if you look on the stand over there, we've got a carbon sensor that will begin to measure that soil carbon. And that technology is really moving fast with the new graphene technologies and other technologies that have been brought in. And I think that begins to answer the question that you asked. We're very close to getting a clever and reliable audit of those things that you want to measure and keep a hold of.
Just a quick point on the sensors, actually. There are 2 versions down there. One of them, they're both commercially available. One of them will use data in the cloud, a training data set, to convert the signal into a value of carbon. And the other one gives you a raw signal, just like a load of squiggly lines on a graph. And we're experimenting with those 2 now, because one of them, of course, you're at the beholding of the company that owns the data. The other one, you can build your own data set. So we're trying to do that for the Southwest. So again, if people are interested in that technology, please let Rupert know. So our plan is to build a data set of thousands of points, collaborating with colleagues up here, so we can build an open access database that can be used regionally rather than being at the mercy of the data owners in the cloud. So I think that point of data ownership is really important at all levels. Time is flying by. We did start a tiny bit late, so can I squeeze one more question out, and then we've got a very short movie to watch, or would you like to go to movie and lunch? Can we have one more question?
Yeah, thank you very much. Neal Parish, politician and a great interest in tractors. A great panel again. The one thing that frustrates me hugely is that there's all this money that's moved around in the city with carbon credits. We fly around in planes, we do all these things, and I'm not convinced for one moment that half that money actually gets to where it's needed. And so what I'm really interested in about is increasing the organic matter in our soils, great grassland in this part of the world. How do we get paid by the city for actually doing some positive stuff on carbon, rather than just making, dare I say it, fat cats in the city, actually stir money around. In fact, I don't think it does any good at all. So perhaps I'm being a bit biased. So what was the panel idea of how we can actually get money into our pockets from the city rather than from government, and actually make a difference on carbon and get recognition for what we're doing?
So, quick answer, please.
Yeah, I'll give you a really quick one. I think one of the challenges we have at the moment with that that sort of emerging market is that we need to not come away from the fact that at the fundamental level, we need to reduce our greenhouse gas emissions because we're in a climate crisis. So absolutely there is a place for offsetting, absolutely there is a place for those carbon markets, but it does not need to be at the expense of the fact that we will continue to do what we do today, and we will just solve the problem by going and planting trees or doing all those other things, which again potentially have some dubious claims. Now I think also, going back to what Tom was saying about being able to value that asset and understand its worth for you as a farmer, there is potential in terms of those developing carbon markets. What they rely on at the moment is having that accurate, that robustness, so that, the people that manage the risk of those funds are confident. I had a lot of conversations very early on with people that went, right, brilliant, let's, we've got all this money, can we come and spend it with farmers? And then you say, well, how are you going to measure it? And you could see the colour come out of their face in terms of they're realising it is quite complicated. And I think, so it's about, as I said a minute ago, having those robust measurement systems, which means that if farmers are taking the risk, the benefit goes back to the farmer and we don't have it going in the brokerage system in the middle. But we also need to make sure that, as we've pledged as an industry to be at net zero 10 years earlier than other industries, we need to make sure that we can help our own industry before we then look at our ability to move widely. But, we need to pilot these systems. And I think through piloting different approaches from a measurement, from a model-based system, we can then start to work out where how the money travels with the risk, and actually how do those two things align in terms of developing a system that will work.
Fantastic. Thank you, Becky. So all that remains now, we can watch a short movie clip. This is an upcoming film coming out of Cornwall, so I'd like to share that with you now, and then we shall break for lunch.
Farming is in Cornwall's DNA, but are these peaceful rural scenes actually contributing to climate breakdown?
We have literally a matter of years to avoid dangerous, potentially catastrophic climate change.
We need to stop tinkering around the edges to make livestock farming less bad. It can't continue if we're going to have a livable planet.
Farmers are the ones that have the answers to these problems. We are the only sector that can provide a climate solution through the act of growing food.
In the farming community, we're a bit slow in getting going sometimes, and somebody has to be an oddball to make it work, and that's me.
Soil is our best hope to take carbon out of the air.
If you do it right, then it has the potential to really change the planet. It started in Cornwall.
No fear or no surprise, there is no way you can deny. Too many holes too big to mend. I've got no time left for you, my friend.
Marvellous. I think we really look forward to that coming out, and it really captures the essence, I think, of the discussion we've had today. So as we go to lunch, I'd like to say thank you very much to our four speakers for, one, keeping to time, but two, for very stimulating discussion as well as presentations. So thank you very much.